So I had a few emails from people asking about what to do when asked to find a polynomial with given zeros, particularly when the zeros that you are given have radicals in them. So I wanted to go through an example of that. So here I'm being asked to find a polynomial with zeros of 5 plus root 3, 5 minus root 3, and 2. And so if I'm going to do that, first I'm going to set up my factors. So x minus, and I'm going to go ahead and protect that 5 plus root 3 with a set of parentheses. Same thing with that next one, x minus, and in parentheses, 5 minus root 3. And then that last factor of x minus 2. And now I'm going to have to multiply these things together. Before I can do that, I want to get rid of these internal sets of parentheses by distributing this negative here. So this is now going to look like x minus 5 minus root 3. And this one is now going to look like x minus 5 plus root 3. And then that x minus 2, which we don't change at all. Now we need to go ahead and start distributing everything in this set of parentheses with everything over here in this set of parentheses. And I'm just going to deal with this x minus 2 once I'm done taking care of these two factors distributions. So x times x will give me x squared. X times negative 5 will give me negative 5x. And x times root 3 will give me root 3x, and it is a positive root 3x. So now this x has been distributed with everything here. Now I'm going to do the same thing with this negative 5. Negative 5 and x will be negative 5x. Negative 5 and negative 5 will be positive 25. Negative 5 and root 3 will give me negative 5 root 3. And now I'll distribute this negative root 3 to all these three terms. Negative root 3 times x will give me negative root 3x. Negative root 3 and negative 5 will give me positive 5 root 3. And negative root 3 and positive root 3 should give me negative 3. And so this is one big messy factor here, along with that x minus 2 that we haven't distributed yet. Before we start to do all that distribution, though, we should simplify what's in here. What we should see happening with these is that anywhere that there's a radical, for this particular pairing where they're conjugates of each other, we should see that there's an opposite in here somewhere to cancel with it. So positive root 3x, there's a negative root 3x in that expression as well. So these two will cancel because they're exact opposites of each other. We have a negative 5 root 3, but there's also a positive 5 root 3, so those two things will cancel each other. And then everything that's left behind at this point no longer has a radical, so I'm going to go ahead and clean it up and then carry on with the distribution. So I have an x squared, I have a negative 5x and another negative 5x, so that would be negative 10x. And then I have a 25 and a negative 3, so that would give me 22. And then that x minus 2. And so from here, I would again start going through and distributing everything here with everything here to see what I get. So x squared and x will give me x cubed. X squared and 2 will give me negative 2x squared. Negative 2x and x, negative 10x squared. Negative 10x and negative 2, positive 20x. 22 and x is 22x. And 22 and negative 2 would give me negative 44. And so now I will again just combine like terms. So x to the third. Here I should get negative 12x squared. 42x. And 44. I hope that helps. Please let me know if you have any more questions.